Hey guys, do you know that there is a formula in dynamic that we can use to calculate the time for the train to stop?
Oh yeah, I remember that. I think you can use the formula dv equals to adt to solve it.
Hey, the train is coming. Let's go back and solve this.
So after we have execute the whole videos and we've used the LRT as the real life example, now we have came out with a report about our whole video assignment. So this is our report. And then we included several things. The first thing is abstract. So it say that dynamic is the whole things that is a whole course that we are studying is a study of the motion of objects such as kinematics and the forces responsible for that motion, and it is also a branch of classical mechanics involving primarily Newton's law of motion. As a field of study is very important for analyzing systems consisting of single body or multiple bodies interacting with each other. So a dynamic analysis is what allows one to predict the motion of an object under influence of different forces such as gravity or spring. It can be used to predict the motion of planets in the solar system or time it takes for a car. In our example is a LRT to a full stop. So nothing that move can be analyzed without using dynamics concept, which means that dynamic is very powerful in describing moving objects. So this is our introduction, and in this case we are demonstrating 3 dynamics learning outcomes. One is using a real life example, which is light rail transit LRT. So the first learning outcome is solve dynamic problem of accelerating particles, which we will come out with a solution. And then second learning outcome is to solve problems of accelerating rigid bodies in 2D, which in this case we will draw a free body diagram and also a kinetic diagram to help visualize all the force acting on it. And then the frictional force and air resistance are neglected in this case. And then next, the third learning outcome is to analyze kinematics and kinetic problems in vibrating particles. So what we have learned in dynamics in this 14 weeks, we will employ the knowledge to analyze on the kinematics and kinetics. So now let's move on. Here is some glimpse of our video, which they have discussed about the formula that we have learned to calculate the time for the LRT to stop. So the methodology is we have drawn out the free body diagram and the kinematic diagram.
So in this situation, we have a train moving to the left and decelerate until it stops. To draw out the free body diagram, we first have to draw all the forces acting on the train. The first force that acts on the train is the force by the engine, which moves the train to the left. And the second force is the weight of the train itself moving downward, and another force opposite to the weight, which is the normal force. For kinetic diagram, we have F equal to ma in the left direction with a negative a because the a is decelerate. For this question, we assume that the initial velocity before the train decelerates is 40 meters per second, and it's given that the formula for the acceleration is negative 1/20 t plus 10 meters per second square. To find the elapsed time when the train comes to rest, we can use the formula dv equal to adt. Then integrating both sides. For v, we are integrating from 40 to v, and then for t, we are integrating from 0 to t. Solving this, we will get v to be equal to negative 1/10 t squared plus 10t plus 40. So we are finding the t when the train come to rest. We can use v equal to 0. So by solving this quadratic equation, we'll get two answers, which is t equal to 103 and also t equal to negative 3.85 seconds. Because t is always positive, so we are negating this. So we'll take 103.85 seconds to be our answer.
And this is our result and discussion, same as the above one. So the force that add onto this object in our case is the reaction force consists of horizontal force and the vertical force. And then by using overall by using dv equal to a dt and the assumption a equal to negative 1 over 20 t plus 10, we can find the elapsed time for train to stop. So this is our reference for the whole report to be used, and also our video assignment. Thank you for watching.